Okay. Systems of equations. So this video will serve as an introduction to systems of equations. And basically a system of equations is two equations with two variables. Okay, so basically you'll have an x and a y. For a long time you'll have x and y as your two variables, and you'll have two equations with x's and y's in them. Now we want to find a point where those two equations connect, where they intersect. One point that will work in both of those equations. So that's what we're saying here. So jot this down if you're taking notes. Systems of equations, two equations with two variables. We want to find the point of intersection, or the x and the y, that will work in both equations. That's what we're doing. Okay, so now for an example, we're going to do an example here. I write EX for example, and we're going to have an x and a y in both of our equations. So 2x plus y equals 8. 2x plus y equals 8. And then x minus y equals let's say 4. Okay, so this is two equations with two variables. You can see that we have 8 and we have 4, and we're going to solve this system of equations. There are different ways of solving. But we want to know what point will work in both equations. So what point will work in both equations? Okay, so we know the answer to this system of equations is going to be what? What point will work in both of these equations? In this case, I believe the answer is going to be 4, 0. Okay? And so let's do a check of that and see how 4, 0 would work. So we have on the top equation, right? We're going to do a check on the top equation first and use 4 for the x and 0 for the y. So we would have 2 times 4 plus 0. That's your x and there's your y, equals 8. So we subbed in 4 and 0 for x and y, and that works because 2 times 4 is 8. 8 minus 0 is 8. So there's a check there. And now in our second equation, we have 4 minus 0 is 4, and that works again. So when we sub in x minus y, again it works. Okay, so next we're going to do some examples of substitution. So we're going to show an example of substitution here. It may be a little harder, but hopefully you can apply and understand that they're going to intersect at a point.
Can you read me 17?
Okay, now the volume on this first section is very low because there's a mistake made here. So it's good to see what's going on, but at the same time you want to understand that there's going to be a mistake and we're going to have to fix this. But I wanted to show you that, you know, it's okay if you make a mistake, you just got to catch it later on, okay? So listen in, and you'll catch a mistake in just about 30-40 seconds here. We'll catch it ourselves.
One for x or for y?
For x, for y.
For y?
X.
Let's write out the bottom equation first. This is what we're going to solve. You want to get x alone or y alone?
Y alone.
We're going to get y alone. So we're going to get rid of the 3x here, rid of the 3x here. So we have 3y is equal to negative 3x plus 13.
It's minus 13.
Right? Oh, you're right. Good catch. Thank you. So that's a minus. Okay.
And then we want the y alone, so we divide it by 3.
Oh. Dividing by 3 here. Yep.
And then y is equal to negative x.
So y equals negative x.
Minus 13 over 3.
Okay, I'm good with that. That's good for y. Let's double check that we copied everything down, because this is a bad looking, yep, there it is. I see the mistake already. Take a look here. This, when we wrote out the original problem, should not have been 13. It should have been -3. Okay, look at the worksheet again. Makes this 1 go away here.
Oh yeah, I see.
Makes this go away. Makes this go away. Making this problem y equals -x minus 1. So now we take this component here, right? And we got to put it into
-3x minus 4y equals to
into
2.
this one, right? It has to be into the other equation that we haven't used yet. So let's do that. -3x minus 4y, but y is this, right?
Yeah. Plus 4x plus 4 equals to 2.
Very good.
And then is x plus 4 equals to 2 minus 4 is equal to 2, -2.
Now what can we do with that?
We can put in which operation we want to.
Put it on for either one. And what do you think is going to be the easiest? I think maybe it doesn't matter. Okay? Let's go ahead and put it into the second one. 3x, which is -2. You're going to have to look back if you don't remember
Plus 3, wait,
that. Or plus 3y, right?
no, minus 4y.
No, I'm using the bottom one.
Oh yeah.
So -6 plus 3y equals -3. Add 6.
It's 10 over
Add 6. 3y equals 3.
-3.
Well, this is a positive,
Oh
right?
yeah, yeah, sorry.
So this is
Y is equal
y
to
is
1.
equal to 1. And that's our answer, and we should write it like this as an ordered pair. Okay? This is the point. So that is our answer. Good? Very good.
Let's check.
You want to check?
Why not?
All right. Well, laziness, I guess. So we have -2, comma 1. Let's try that. -2, comma 1. See if that works. Okay, so if we put -2 here, we get. Let's do the check in blue. The -2 times the 3 would give me.
-6.
Yep. And then what did we say our y was?
For y you have positive 6.
For y we had what? Sorry, because it's a negative times a negative. Hang on. For y we have 1. I'm in trouble here. For y we have 1, so we have -4, right?
Yes.
Okay. And I have 6 because
Equals to 2.
this was a -3 times a -2.
Yeah.
Okay. So that's working. Then we have -6 for the bottom equation. Plus 3 equals -3, and that's true too. So we know we got the right answer. Good work. Good work. Okay. So now moving on, we go to our new page. Okay, what's our example now? Number 19? Could you read me?
5x.
And let's make sure we're writing down the right problem. So we got -5
x minus 8y
minus 8y.
equals to 17.
Okay.
And 2x minus 7y equals to -17.
Good. Okay. Which one do you want to solve? Top or bottom?
I don't know, because both of them look hard.
Well, maybe solve the bottom for x. Okay, let's do that. Okay. And 2x minus 7y equals -17. We want to solve for x, so let's get the 7y out of there. 2x equals 7y minus 17. Right? So now we have to divide by 2. So when we're dividing both sides by 2,
7 over 2y
7 over 2y
minus 17 over 2.
minus 17 over 2. That's fine. So now we got to put that into the top equation. We have to put it into the top equation. -5x.
7 over 2y
Good. 7 over 2y
minus 17 over 2 equals to 17.
minus 8y good. Okay, so we're going to have negative 35 over 2y minus,
Plus.
oh, plus, good. 50 and another 35, I'm 85. Okay, that's just my math skills working for me there. Good. We got to minus another 8y, so what do we got? This is a whole lot of minuses, so let's see. Oh.
Negative 35 minus a. It should be.
Yeah, but this needs to be over 2, so let's change this to 16 over 2, right?
Mm-hmm.
That would work.
Yes.
So what's 16 and 35? That's 40, that's 51 over 2.
Mm-hmm.
They're negatives.
Plus 82 over 2.
85 over 2.
Equals to 17.
Good. Let's do what I like to call multiplying everything by 2 to make this equation a little bit better looking. So when these are multiplied by 2, the 2's get canceled out, right? I multiply everything by 2. You see this?
Mm-hmm.
And then I multiply this by 2. 17 times 2 is 34. Okay?
Mm-hmm.
Negative 51y. We have to minus the 85. Minus the 85. 34 minus 85, what are we going to get there? That's a tricky one. I think it's going to be a negative 51.
It's equal to 51.
What's this going to be? Y is equal to 1?
Yes.
Good. So now we need to go back to our other equation, or either equation really, and solve. So let's solve this equation, which was our bottom equation originally.
2x minus 7 times 1.
Yep. So we're going to put 7 times 1 in instead. So 7 times 1, and so minus is just going to give me the 7. So this is because this is equal to 1, right?
Mm-hmm.
Equals 1. Add 7. Adding 7. Adding 7, sorry.
12.
2x equals, well no, because 17 and 7, this is going to be, so this is going to be negative 10. Dividing by the 2, dividing by the 2, x is equal to?
5.
So our answer as a point is negative 5, 1. That's it.